Welcome to math class, ladies and gentlemen. I'm trying something new today and recording my own video. I'm going to encourage you to pause the video numerous times during this lesson today, so make sure you're following directions. Remember, you can always go backwards and reverse through the video to listen to something again if you didn't capture anything. First thing you should have is that your ratios and proportions pre-test is due today. You should have that in your notebook or Notability from Thursday or Friday last week. I'm going to have you pause the video. I want you to check your pre-test. For number 3, yes, you have to have all 3 correct to mark that as a correct answer. Please submit your answers in the pre-test form on the home page of my blog, and then come back here. So go ahead and pause the video and come back when you have corrected and submitted this. All right, thank you for submitting your pre-test information on the blog. Today we are starting our new unit on ratios and proportions. This is going to be a big unit for us. It's a big major focus in 7th grade math. Throughout this unit, you're going to learn to compute unit rates, determine if 2 quantities are proportional or not, identify the unit rate in tables, graphs, equations, diagrams, and word problems, identify the unit rate on a graph and interpret any point on the graph, use proportions to solve multi-step ratio problems. I can reproduce a scale drawing, which yes, we are going to do some drawings, and everybody will be able to do it, no matter how artistic you are. And then compute actual length of a figure from a scale drawing. So we have several projects and things that we will also be doing throughout this unit. So those are all the things that you will be able to do by the end of this unit. Today, we are going to start with Chapter 5, Section 1. So please go ahead and pause the video for a second and title your notes and write the I can statement. So today, 5.1, ratios and ratio tables. And our focus today is number 25, I can compute unit rates. So go ahead and pause the video and hit play again once you've titled and written your I can statement. All right, here we go today. Ratios. A ratio compares 2 quantities, okay? It's just comparing 2 different things. It's different from a fraction. A fraction, like if you have 3/4 of a pie, you have just part of that pie. We're comparing 2 different things. We're going to have 2 different labels and some of those things. A fraction can be a ratio, so labels are going to be very important. There are 3 ways to write the ratios. You have to be able to recognize all 3 of them. The first way to write one, if we're comparing, like if 34 students are right-handed and 5 students are left-handed, 3 different ways to write it would be to write it 34 to 5 using the colon, or 34 to 5 using the word 2, or writing it as like a fraction. We would still read this as 35 to 5. Notice how these are not all labeled. Yes, labels are going to be very important, but over here, I have written the left-handed or right-handed to left-handed. Because it's right-handed first, then left-handed, the 34 to 5 represents right-handed to left-handed. So order and labels are going to matter. If right-handed is listed first, then the first number in the ratio is representing right-handed. Ratios are written as fractions, and just like fractions, they have to be written in simplest form. The only difference is we are not going to write them as a mixed number. So notice here you have 34 to 5 right-handeds. If we change that to a mixed number, you would lose that ratio, and it wouldn't make sense in that context. So we are going to be working with ratios similar to fractions. They can be simplified and should always be in simplest form, but we cannot change them to mixed numbers. And then the order we talked about, the order of a ratio is really important in paying attention to the labels. And if they tell you to go right to left-handed, then you have to make sure your numbers represent that and go right to left-handed. All right, so what I want you to do for a second here is draw a picture to show the ratio 3 triangles to 5 squares. I want you to show that as a picture. So pause this video and just quick draw 3 triangles to 5 squares. Okay, now on your paper, to draw 3 triangles to 5 squares, does your paper look similar to this? 3 triangles to 5 squares. But my question is, all together now, all of those triangles together and all of those squares together, does that represent 3 triangles to 5 squares? Is this the same thing or an equivalent ratio to this? And the answer is yes, because here for every 3 triangles, there are 5 squares. Just like on this side, there are 3 triangles for 5 squares. Okay, so now what I want you to do is draw the ratio 4 circles to 6 triangles. So pause the video and draw 4 circles to 6 triangles. Okay, so how did you do in this one? Did you draw 4 circles to 3 triangles? Did you draw 8 circles to 12 triangles? Okay, there's many different options to show that ratio and still have it. There are many equivalent ratios. The other thing you can do is, remember I mentioned earlier, you can simplify ratios. So does this also have the same ratio that 4 circles to 6 triangles does? Is this equivalent to this? And the answer is yes, because 4 can be divided by 2, which is 2, and 6 can be divided by 2, which is 3. So the ratio 2 to 3 is equivalent to the ratio 4 to 6. So this would be an equivalent ratio of 4 circles to 6 triangles. So remember when we worked with fractions, this is one of the things we struggle with most, simplifying. Yes, you can use your calculator to help you, and I'll show you a couple things with that here, but I want you to just simplify, try simplifying all 3 of these with your partner. So go ahead and pause the video, simplify these, and then come back and we'll explain. All right, have you tried to simplify these? Now 30 and 40, what can you divide both 30 and 40 by? They can both be divided by 10. Remember, whatever you do to one number, you must also do to the other number when you're simplifying. Just like we did with fractions, ratios work the same way in simplifying. So if you divide the first number by 10, you have to divide the second number by 10. So 30 to 40 will simplify to 3 to 4. Now 75 to 25. And notice it was written with the colon, and I changed it to writing it with the fraction bar kind of here. You can write them either way. Some people like to keep them this way. Some people like to keep them here. It's your preference. I will say that a lot of people, based on where we're headed, will probably end up writing ratios this way most often. All right, so 75 to 25. Think about quarters there. What can I divide both 75 and 25 by? I can divide them both by 25. If you divided 75 and 25 by 5, you would have to divide by 5 another time to get to your simplified ratio of 3 to 1. Now, when we were working with fractions, you could have it as 3 to 1 or just the answer 3. When we're working with ratios, you have to leave it as a ratio. So you have to have the 1 as your denominator here. Because if you're comparing apples to oranges, if you have 75 apples to 25 oranges, you have 3 apples to 1 orange. So you lose those labels or that ratio if you don't have that 1 there. So when we are working with ratios, you have to make sure you keep your numerator and your denominator. So if it's a 1, you still need it there. And labels are going to be a big thing. Even though it's improper, that's how we want it. No mixed numbers. All right, and then 50 to 32. Both of those are divisible by 2, which gives you 25 to 16. And those have no common factors. So that's in simplest form. Using your calculator on these, remember you can clear out your calculator, make sure it's good and clear, and then you can put in like 50, ABC 32, and then you can hit equals, and it should simplify it for you. If you do that with the 75 to 25, so if you clear out your calculator and you put 75, ABC 25, and hit equals, you are going to just get an answer of 3. But then you need to know that you need to put it over 1. So it would be 3 over 1. All right. What I want you to do now is go ahead and pause the video. And I want you to go ahead and simplify these 3 ratios with your partner. And once you have that done and you've compared, then go ahead and hit play again. Okay, now that you've simplified these, 8 to 14, they are both divisible by 2, so it should simplify to 4 to 7. Okay. 36 even to 12 odd should simplify down to 3 to 1. So it should be 3 even to every 1 odd number. Okay. Notice I didn't put labels. Do you see how putting the labels here makes it make more sense and meaningful? So in your answers, you should have 3 even to 1 odd. So here again with the labels, you should have those in your answer. So if it's 48 vanilla cookies to 42 chocolate cookies, that simplifies down to 8 vanilla cookies to 8 vanilla cookies to 7 chocolate cookies. Okay, so you're going to want to use those labels and stuff as well. All right, writing ratios. Okay, using the word mathematics. Okay, and writing ratios. Comparing vowels to consonants. Vowels for this are A, E, I, O, and U. Okay, so comparing vowels. How many vowels are there here? And then how many consonants? And that's what you're going to write. Notice there are 4 vowels. A, E, A, I. So there's 4. The rest of the letters are consonants. So you have M is 1, T is 2, H is 3, M is 4, T is 5, C is 6, and S is 7. So your ratio there for vowels consonants would be 4 vowels to 7 consonants. I want you to go ahead and pause the video and do numbers 2, 3, and 4 with your partner. Hit play once you have written those ratios. Okay, welcome back. So, checking your answers. Number 1 we went over, you should have 4 vowels to 7 consonants. On number 2, there are 7 consonants to 11 total letters. On number 3, there are 2 A's for 4 vowels. That should not be your final answer though, because remember, just like fractions, ratios should always be in simplest form. So your final answer should be for every 1 A, there are 2 vowels. Do not forget to simplify. Number 4, comparing the number of M's to total letters. There are 2 M's for a total of 11 letters. Okay. All right, we're going to keep practicing with some of these. So here, there are 27 cupcakes. 9 are chocolate, 7 are vanilla, and the rest are strawberry. What is the ratio of vanilla cupcakes to strawberry cupcakes? So think about that. What is the ratio of vanilla, 7, to strawberry? How many strawberry cupcakes are there? Well, I know there are 27 cupcakes. I know 9 are chocolate, so if I take 27 minus 9, that gives me an 18. I know there are another 7 that are vanilla, so if I take 18 minus 7, that gives me 11. That means there are 11 strawberries. So my ratio of vanilla is 7 to 11, which is C. All right, here, same scenario, but now what is the ratio of chocolate cupcakes to total cupcakes? Think about this, pause and check with your partner, and then hit play when you've checked with each other. Okay, the ratio of chocolate to total. There are 9 chocolate and 27 total cupcakes. So many students want to use the answer of C, but C is not correct. 9 and 27 can both be divided. And so this is not in simplest form. Your simplest form is D. So the ratio of chocolate to total cupcakes is 1 to 3. Okay, do not forget to simplify. Just like fractions, the directions aren't going to always say to simplify, but you have to always put your final answer in simplest form. All right, here. Now, what is the ratio of total cupcakes to vanilla cupcakes? Notice there are 27 total cupcakes. So that could leave it as either A or C. And then vanilla, there are 7. So that means your final answer there is C, 27 total cupcakes for every 7 vanilla cupcakes. All right. Now, we're going to move on to a little bit something different and looking at kind of what some of these ratios mean in recipes and stuff. I don't know if any of you have ever made flubber or slime or some of those kinds of things, but here's a recipe for flubber that has has 3/2 cup cold water, 4/3 cup hot water, 2 cups glue, and 3 teaspoons of borax. Okay, so using this, what is the ratio of cold water to glue? So if we look over here, cold water was 3/2 cups for every 2 cups glue. So that's my ratio, 3/2 to 2. Notice that's right there. Okay. Now, interpreting these. So what does that really mean? Okay, so we've written this ratio this way. Notice we can also write it kind of as the fraction, 3/2 to 2. So there's 3/2 cups cold water for every 2 cups glue. When you write it this way, remember this can also mean the division bar. So we could also be thinking 3/2 divided by 2. Okay, you can either at this point type in 3/2 divided by 2 on your calculator, or remember when you're multiplying fractions, you change it, or dividing fractions, when you're dividing fractions, you change it to multiplying by the reciprocal. So 3/2 divided by 2 is equivalent to 3/2 times 1/2. If you type in either one of those in your calculator, you're going to get 3 to 4, okay? So the relationship then is 3/4. The amount of cold water in the recipe is 3/4 the amount of glue, okay? So looking at that, that's helping us see how that relationship is between the cold water and the glue. So we're going to try this with a couple other ingredients on this flubber recipe. This is something you will have to be able to do on your homework assignment. Okay, so on this one, if we look at the ratio of cold water to the ratio of hot water. So I want you to think for a second, what is that ratio of cold water to hot water? Notice here the recipe uses 3/2 cups of cold water per 4/3 cups hot water. That should be hot water. Ignore that for a second and pretend it says hot. Okay, so then to figure out, so we've got this ratio here. To figure out what that means, that multiplication relationship there, we are going to divide the 3/2 by 4/3. So on your calculator, you can just take 3/2 divided by 4/3, which remember your calculator really is changing it to multiplying by the reciprocal, which ends up being 9/8. Okay, so the amount of cold water is 9/8 the amount of hot water. All right, so you're taking this ratio and instead of writing it with colon, you're writing it with the fraction kind of, or the ratio form using that division bar, and then doing the division to find out what that relationship is. All right, so here I want you to think about, you mix 2/3 teaspoon of baking soda with 3 teaspoons of salt. I want you to find the ratio and then find and interpret that value. So go ahead and do that division. I want you to pause this video once now and then go ahead and do that with your partner. Once you have it done, go ahead and check back here for your answer. Okay, so your ratio should be that you have 2/3 teaspoons baking soda per 3 teaspoons of salt. So 2/3 to 3 is your ratio. Okay, and then you're going to go ahead and do that division. 2/3 divided by 3, which is 2/9. Okay, so the amount of baking soda is 2/9 the amount of salt. So when you do this for homework, you first need to have this ratio here, and then you need to have the division and be able to tell me this here. So basically what's in the bold, you need to be able to tell me. All right, I want you to go ahead and try this once more, looking at the ratio of dogs and cats at a pet store. So go ahead and pause and find and interpret the value, and then come back and hit play. All right, so your ratio should be 15 to 12, which simplifies to 5/4. Okay, did you try typing that in your calculator? If you type in 15 ABC12 and hit equals, it will give you a mixed number. But remember, if you go back and hit the ABC button again, it will toggle between the decimal, the mixed number, and the improper fraction. So if you type in 15 ABC12 equals, and then you hit that ABC button a time or two again, it will come back and show you that 5/4. Remember, we're not changing these to mixed numbers for ratios. We're leaving them as improper fractions. All right, so then the ratio is at 5/4. So 5 divided by 4, okay, and you can leave it as the fraction there, or which makes most sense as we're working with ratios. So then the number of cats at the pet store is 5/4 the number of dogs. Okay. Now, ratios that have the same amount are called those equal ratios or equivalent ratios. They look and function like fractions. So think about equivalent fractions and think about the fraction 1/2. Can you name several fractions that are equivalent to 1/2? 2/4, 3/6, 4/8. I mean, you can go on and on with equivalent fractions. So equivalent fractions and equivalent ratios function a lot the same way. So notice here, 3/2 is equivalent to 6/4 because 3 times 2 is 6, 2 times 2 is 4. Whatever you do to the first number, you have to do to the second number, just like with fractions. So here, 1/3 is equivalent to 9/27 because 1 times 9 and 3 times 9, okay? And then 5/6 is equivalent to 35/42. Whatever you do to the first number, you have to do the same to the second number. And again, ratios can be written in these 3 different forms. I will tell you that for most part, we're going to probably be writing it this way. I've had students in the past that really like writing it this way or this way, and that is your choice. But overall, this is probably kind of where we'll end up wanting to be. All right, so again, multiplying or dividing by the same number. So whatever you do to one, you do to the other. It must be multiplication. It must be division. It cannot be addition or subtraction. When you're looking at equivalent ratios, you have to be multiplying both numbers by the same thing or dividing both numbers by the same thing. All right. So equivalent ratios and equivalent rates, they name the same number or the ratio. They're just function just like equivalent fractions. To find equivalent ratios and rates, you're multiplying or dividing both parts of the ratio or rate by the same number. So let's look at a few of these. Think about this for a second. If we have 4 9s, 4 to 9, is that equivalent to 8 to 18? You can check that by looking at multiplying. 4 times what is 8? 4 times 2 is 8. 9 times 2 is 18. As long as they're multiplying by the same number, they are equivalent ratios. So are these equivalent ratios? Yes. Okay, this one is 5 to 9 equivalent to 30 to 45. 5 times what is 30? 5 times 6. Okay, 9 times 6 is 54. So are these equivalent ratios? Yes. Okay. So I want you to look at these and let's think about finding and making equivalent ratios. So if I have the ratio of 72 to 64, that is equal to the ratio 9 to what? So think about here, 72 to 9. 72 divided by 9 is 8. 72 divided by 9 is 8. So 64 divided by 8 is 8. Okay, so sometimes you're going to be dividing both numbers. Here, if we look at this one, I know these two, the second ones, 7 to 14. You can think about it from 7 to 14, I'm multiplying by 2. Or if I'm moving this direction, I'm dividing by 2. So 8 divided by 2 is 4. Here, I'm going from 2 to 14. How do I go from 2 to 14? Using multiplication or division, only multiplication or division. 2 times 7 is 14. So 6 times 7 is 42. Those are my missing ratios and making equivalent ratios. Okay, so on these three ratios, I want you to go ahead and pause and write these equivalent ratios and talk about them with your partner. All right, let's check these and see how you did. Notice here, I went from 3 to 6. 3 times 2 is 6, so 4 times 2 is 8. So check, did you have 8 there? On this one, we went from 4 to 20. 4 times 5 is 20, so 2 times 5 is 10. On this one, we went from 63 to 7. So 63 divided by 7 is 9, okay? Or 7 times 9 is 63, so 2 times 9 is 18 is your missing number there. So when you're working with equivalent ratios, sometimes it's nice to have a table to organize those equivalent ratios. So here's an example of a ratio table. Here we have, if you're at a carnival and it costs $5 for 20 tickets, okay? Notice $10 for 40 and so on their table. When you're looking at ratio tables, again, you have to be looking for multiplication or division relationships. So when I go from 5 to 10, I'm multiplying by 2. And notice then here, this is multiplying by 2 as well. Or from 5 to 15, I'm multiplying by 3. So here I'm multiplying by 3 to go from 20 to 60. To go from 5 to 20, I'm multiplying by 4. So 20 times 4 is 80. 5 times 5 is 25. 20 times 5 is 100. You're looking at multiplication. So if I'm moving this way, I'm looking at the multiplication. I can start at 100 or 25 and think about 25 to 5. How did I get there? I'm dividing by 5. So here I'm dividing by 5. Or I can look at 20 to 5. I'm dividing by 4. So you're looking at those multiplication and division relationships. Okay? So here's a table, because you're going to have some tables like this on homework that you have to fill in the missing numbers. Okay, so here we know that David paid $15 for 45-minute guitar lessons. So here we have the ratio in the table. I want to know how much it, for $1, how many minutes he got. And then if he did 90 minutes, how much would that cost him? So think about how you would multiply or divide to get there. So go ahead and pause and talk to your partner. Okay, notice here from 15 to 1, we're dividing by 15. So if I take 45 divided by 15, I am at 3. So notice there should be a 3 here. I just found this feature, so sorry that's not very neat, but I can write on them. All right, and then, so notice that we divided by 15 there. Okay, so then, whoops, and then you have to do the same thing there. All right, then, sometimes going from 45 to 90, is there a nice number that you can multiply from 45 to 90 to get there? The other thing you do is look at going from 3 to 90. Think about this. What is 90 divided by 3? 30. So 3 times 30 is 90. So then here I can go to multiplication. 1 times 30 is 30. So it would cost him $30 to get 90 minutes of guitar lessons. Okay, so sometimes you need to find like this ratio, the amount per one or something like that, and that will help it make it easier to find some of the ratios over on the right side of the table. All right, so I have these two ratio tables. I want you to write those in your notes and fill in those missing numbers. So I want you to go ahead and pause and talk through these two with your partner. Okay, let's check and see how you did. All right, notice here our missing numbers. We're multiplying by 2 here. Notice from here to here, we're multiplying by 3. And 5 times 20, we're multiplying times 4 to get to this ratio. And here we're multiplying by 5. Okay. On this one, notice our numbers are bigger and we're going down, so you're looking at a division relationship. 90 divided by 30 is 3, so you're there. So you're taking this divided by 3 and looking at how you go from 90 to 18. 90 divided by 18 is 5. Okay, so dividing by 5 here, or dividing by 9 here, and then dividing by 9. And then 90 divided by 6 is 15. So you're going there. So you need to look at that division. Some tables are going to use multiplication and some are you going to use division. And sometimes you'll have a little bit of both. Okay. Before I have you start homework, I do have a Google form that I want you to fill out. I'm going to go over a couple things with your homework first, just to make sure you understand your worksheet. So your homework is a worksheet tonight. You are going to skip number 10. All right, so the first 5 problems, remember that it says find the ratio and then interpret the value. That is like back to what we did with the flubber recipe. So when it says find the ratio, your ratio of flour to milk, well, flour is here at 3 cups and milk is 2/3 of a cup. So your ratio is 3 to 2/3. And then when it says interpret, that's where we did that division. We took, there we go, 3 divided by 2/3. And you can use your calculator to do that. 3 divided by 2/3, and you can write just this part, and then that equals 4.5. So that means flour is 4.5 times the amount of milk. Okay, so that's what you're going to do for the rest of those on that section. All right, then on these tables, you're filling in the missing numbers. Okay, so you need to go think about multiplication and division. So 2 times 2 is 4, or 4 divided by 2, so 10 divided by 2. To figure out these, if you can't go from the 4 to the 10 here, remember you can always go from here and look at how to go here. Sometimes that will be easier. Fractions, go ahead and use your calculator, do some division to see how you got from here to here. Okay, you can do those. All right, so make sure you go to the blog and get the rest of the steps done and your worksheet, which will be due tomorrow. Yes, you need to make sure that you have the ratio and interpret it and show some work there. All right, and thank you very much. Have a good rest of the day.